Welcome to Chapter 3, Part 2, where we are going to start dealing with direct variations. First, we are going to be asked to graph the equation. And when we graph these guys, we're going to start off by making tables. And I would pick the smallest numbers that you can for these guys. So I'm going to pick -1, and that's a -1, 0, and 1. And you're just going to put them right in for x. So 2 times -1 is -2. 0 times 2 is 0, and 1 times 2 is 2. So now I'm going to take these just like coordinate points and put them in as is. So I -1, so I go to the left 1, down -2, then I'm at 0, 0, and then I'm over 1, up 2, and I am going to attempt to draw a line through those dots. And here goes nothing, and there is my first line. Now for number 2, we have to notice something about this one though. Look at what is in front of my x. When I have a fraction in front of my x, instead of choosing -1, 0, and 1, I'm going to choose the negative number of whatever's on the bottom. So I'm going to choose -3, 0, and I'm also going to make it positive, so I'm going to choose a +3. If that was 2 on the bottom, I would have chosen a -2, 0, and a +2. If it was a 5, I would have chosen a -5, 0, and a 5. And so now we put these numbers in for x. -3 times 1/3 is -1, 0 times 1/3 is 0, and 3 times 1/3 is 1. So now I plot these points. So I go over -3, down 1. I go 0, 0, and it goes right through the middle again. Then I go over 3, up 1, and now attempt to connect the dots. And here is my next line for number 2. Notice the slopes, guys. Notice the slopes. This one is steeper, right? This one is more flat, right? It goes up less. Take a look at these numbers for future reference coming up next chapter. Now, what is this? This is a direct variation. Direct variation, y equals kx, where k acts as your slope, and the graph always goes through 0, 0. The graph always goes through 0, 0. Check this out. Both of these guys are direct variations because they go through 0, 0, and they are a straight line. Next, we have some direct variation equations where suppose y varies directly as x, and so now this directly tells us that it's going to be a direct variation. Write a direct variation equation that relates x and y, then solve. The very first thing we have to do is know the direct variation equation, which is y equals kx. Now, whatever they give you in the first part of the equation, you're going to plug in for the direct variation. So I know y is 6, so I'm going to plug 6 in for y. And I know x is 2, and so I'm going to plug 2 in for x, and we'll leave it k. Now we want to solve for k, so go ahead and divide both sides by 2. So now k equals 2. Good. Now my next step with this k, I'm going to plug this k into my direct variation equation. So y equals 2x. So there is my direct variation equation. Now I want to solve the equation for the last half of the sentence. So now it says find x when y is 18. So now I'm going to take this 18 and put it into your equation you just found. Put it into your equation that you just found. So it's 18 equals this equation, 2x. I'm solving for x, so I divide by 2, and x equals 9. And so I found my x. And this would be an answer, and this would be your equation. Again, number 4, we have to do the same thing. Know what your direct variation equation is, y equals kx. They tell you what to plug in at the start, so y is 15. That equals k times 12. Now we have to divide by whatever is attached to k. So now k, when simplified, equals 5/4. Now we are asked to write the direct variation equation. So let's go ahead and write that down. It's always going to be y equals whatever you just found times x. So there is one answer as I put a box around it. Then what you do is find whatever they ask you to find. So it says find y when x is 18. So I do not know what y is. And I'm going back to my equation. 5/4 times 18. Now I go y and put that in your handy dandy calculator. You get 22.5. So we found what y is. Next, now it's a little bit of word problem. The distance that a jet travels varies directly as the number of hours it flies. Varies directly tells me that it's going to be a direct variation equation. What is that? It's y equals kx. Awesome, there it is. The jet traveled 3,420 miles in 6 hours. Write a direct variation equation for the distance d flown in time t. So now instead of y and x, I'm going to change my variables where now my y becomes my d because it is my independent variable. It depends on what x is. So it's d equals t. So how fast you're flying, which is a rate of change, right? How fast, miles per hour, kilometers per hour. How fast you're flying, rate, times your independent variable. So now I'm going to use d equals kt. So I put my miles in for my d because that is a distance. So it's 3,420 equals k, which we don't know. And how fast did he fly it in? 6 hours. Solve for k. So 6, or divide by 6, divide by 6. And so now k equals, I believe that is 570. Now it says, we didn't solve anything. We said, or it asks, write a direct variation equation for the distance flown. Well, I found my k, which is a great start. So now you have to plug this k into that equation. So now it's d equals 570 t. So this is your equation. You found k to plug back into your big equation. Now it says, estimate how many hours will it take for the jet to fly 6,500, and I should have put miles here at the end, miles. Well, what is 6,500 miles? It is a distance, so I'm going to put that 6,500 in for d, in for this d in this equation. So it's 570 t. Solve for t. Divide by 570. Divide by 570. So now t equals 11.4. But 11.4 what? 11.4 hours because we're talking time. Next, we're going to move on to arithmetic sequences or arithmetic sequences. Now, arithmetic sequences are sequences that move term to term. So this would be a term, this would be a term, that would be a term, this would be a term, by either addition or subtraction. They move left to right. Doesn't matter if you're adding or subtracting. So we have to figure out what is the difference between -3 and 1. Well, let's try plus 4. -3 plus 4 is 1. See if it continues the trend. Add 4 there. 1 plus 4 is 5. Add 4 to there. 5 plus 9 is, or I'm sorry, 5 plus 4 is 9. Perfect. So it is an arithmetic sequence with 4 being the difference. Now let's say you didn't know it was going to be that easy. You could always work backwards and subtract. You could always go 1 minus a -3, which would be 4. You could subtract 5, or 1 from 5 and get 4. And again, 5 from 9 to get 4. All these differences are 4, so it is an arithmetic sequence. Now we are asked to find the next 3 terms. Well, how do we find the next 3 terms? We have to add 4. So 9 plus 4 is 13, plus 4 is 17, plus 4 is 21. So your next three terms are 13, 17, and 21. Now we are asked to write an equation for the nth term of the arithmetic sequence. Alright, well, the formula or the equation for an arithmetic sequence looks something like this. What do these things stand for? Well, here we go. A sub n, so this guy right here is the final term of your sequence. A sub 1, which is this guy, is the first term of the sequence. N is the number of terms, and D is the difference between the terms. So here is our sequence right here. Do we know what A sub n is? No, we don't. That's alright for our nth term. How about A sub 1? What is our first term? Our first term is whatever it starts with, so that's negative 3. How many numbers of terms do we have for n? We don't know that either. Do we know the difference? How do we get from one term to the next? How are we going from negative 3 to negative 8? Well, we are subtracting 5, so our difference is negative 5. So now all this stuff that we know, let's plug it in for this equation. A sub n, we just said we don't know. A sub 1 is negative 3 plus, how many terms do we have? We don't know again. Minus 1 from our formula and times our difference, negative 5. Now you could keep it like this, but I'm going to go one step forward. What do you think we can do with this negative 5? We can absolutely distribute that, so it's going to be negative 3 plus negative 5n plus 5. Can we keep going? A sub n equals, we have a like term here and a like term there to add up to a positive 2 minus 5n, and I bet we have seen this equation or equation that looks like this sometime before. 8. Last and final one. Write an equation in function notation for this relation. Well, what is function notation? Function notation, all it does is change the y to an fx. A y to an fx. Nothing really else changes for right now. So now, on our graph, we have to find 2 points that it goes through. Well, I see that it goes through 0, 0, and I keep going up the line. Oh, and it goes through that point. So it goes through 0, 0, and it goes through 2, 1. Now, how do we write an equation? This m represents the slope. So we have to find the slope of this line. So I'm going to do it the old-fashioned way, xy, xy. Remember, y minus y, x minus x, rise over run for slope. So we have 0 minus 1 over 0 minus 2, which turns into negative 1 over negative 2, simplifies into 1/2. We found our m. Also, you could have counted up 1 over 2, so we're going to put that in for m. So we have f of x equals 1/2 x. And that does it for Chapter 3, Part 2.